So as I mentioned yesterday, today we're kind of shifting gears. The first big chunk of this module we talked about what concept? Volume. Then the second big chunk we talked about? Area, yeah. Remember, volume is how much space a 3D figure, a three-dimensional figure takes up, and area is the amount of space a 2D figure takes up, okay? Now today we're going to kind of shift into the third big chunk of this lesson, and we're going to be talking about two-dimensional shapes, otherwise known as polygons. Okay, we're going to be talking about different kinds of polygons, what their names are, what their attributes or their properties or characteristics are. We're going to sort them, draw them, measure them, and talk about how, what makes different shapes or different polygons different and the same from each other. Does that make sense? So today your learning goal is to be able to draw and sort trapezoids and parallelograms. So the two main shapes today that we're talking about, or two main polygons, are trapezoids and parallelograms. You need to know what makes a trapezoid a trapezoid. You need to be able to draw, specifically using angles and measurements and rulers, these different figures, okay? And parallelograms as well. Let's first talk about the problem of the day, though. The first word today we are going to write down is the word polygon. A polygon is a closed 2D figure with 3 or more lines. So, for example, 1, 2, 3. That's a closed figure that has 3 or more lines. So that's a polygon. 1, 2, 3, 4. Is that a closed figure? Does it have 3 or more lines? That's a polygon. 1, 2. Is that a closed figure? No. Does it have 3 or more lines? This is a non-example. Does that make sense? Okay, that's a non-example. So go ahead and write down the definition for polygon and write an example, or draw an example and a non-example. Now, a quadrilateral is a polygon with 4 sides and 4 angles. Okay, so an example might be like this. 1, 2, 3, 4. Does that have 4 sides? 1, 2, 3, 4. Does it have 4 sides? Okay. Does it have 4 angles? 1, 2, 3, 4. Does it have 4 angles? Yeah, that meets the requirements, so that is an example of a quadrilateral. What about a non-example? Let's take a look at this one. Does this polygon right here have 4 sides? No. Does it have 4 angles? No. This is a non-example of a quadrilateral. Look for where it says parallelogram in your glossary. Quick question about a quadrilateral. If you're copying the definition right now, stop. Eyes up here. We said a quadrilateral needs to have exactly how many sides? 4. And how many angles? 4. Okay. So as we said, this is an example and this is a non-example, right? Okay, what about this one? 1, 2, 3, 4. Is that an example of a quadrilateral?
No.
Why not? Aditya?
Because it doesn't have 4 angles,
It has 1 angle, 2 angles, 3 angles. Why else? A quadrilateral needs to be a polygon. Is this right here a polygon?
No.
Because it's not, what? Closed. Very good. Okay, a parallelogram is a quadrilateral, which already tells us a lot of information. It has exactly how many sides?
4 sides.
How many sides?
4 sides.
4 sides, and how many angles?
4 angles.
It's 4 sides. It needs to say whose opposite sides are parallel and have the same length. Would it make sense if all 4 sides are parallel?
No.
Would that be a closed figure? No. So for parallelogram, make sure you write down that the definition is a quadrilateral whose opposite sides are parallel and have the same length. Okay, so given that, try to draw an example. Remember, you need to have opposite sides that are parallel, meaning that they never touch and that they're the same length. So that would be an example of a parallelogram. Would this one be an example of a parallelogram? No, because these 2 sides are not equal, parallel or the same length. And these 2 sides here are also not parallel or the same length, right? Very good. Let me ask you a question. How many sets of parallel lines does a parallelogram have? 2. Because the opposite sides, these 2, are parallel, and then these 2 are parallel too. Okay, so you have 2 sets of parallel lines. Now, a trapezoid is a quadrilateral, so again, we know a lot of information. We know it's a polygon. We know it has exactly how many sides? How many sides?
4.
Everyone, how many sides?
4.
And how many angles?
4. 4.
But this time, it only has one pair of parallel sides. So a trapezoid might look something like this. One set of parallel lines and one set that are not parallel. Okay, so is this one right here, up here, is that an example or a non-example of a trapezoid? Non-example. Why? Tara?
Because it has 2 sets of parallel.
Right, so a trapezoid can only have one set of parallel lines right here and one set of lines that are not parallel. Okay, so write your definition for trapezoid and draw an example and a non-example. Look for the word right angle in your glossary. A right angle is an angle that measures exactly how many degrees? 90. It can't be 91, it can't be 89, it's exactly 90 degrees. And a right angle, we mark it by drawing a little square like that in the angle. Okay, so an angle that is exactly 90 degrees. Okay, so I didn't write the words for you, but you can write it yourself, right? An angle that measures exactly 90 degrees. You're going to draw a picture, and the only way to show that it's a right angle is by drawing these lines right here. If you don't do that, we don't know. Even if it looks like an L shape, we don't know. But if you write that little symbol there, it shows that it's exactly 90 degrees. An obtuse angle is any angle that is what? Greater than 90 degrees. So if I want to make this angle bigger, it's going to get wider, like this. Okay? And we show angles by drawing this little curved line, and we could say that it's, let's say, 107 degrees. Would that be an obtuse angle? Yeah. A non-example would be an angle that's less than 90 degrees or exactly 90 degrees. Okay, so go ahead and write that down. An obtuse angle is an angle that's greater than 90 degrees. An acute angle is an angle that measures less than 90 degrees. Okay, so if an obtuse angle looks like this, I'm going to fix it, and let's label it 120 degrees. An acute angle might be narrow like this and would measure something less than 90. For example, 60, sure. Okay, and to measure angles and to show what their angle measurements are, you draw this curved line. Do you see how it's different than the right angle, which was straight lines? Okay, so go ahead and write and draw your examples for acute angle. How come it doesn't say separate all of them into quadrilaterals, into trapezoids and non-trapezoids? Are all trapezoids quadrilaterals?
Yes. Yeah.
Can you have a non-quadrilateral, something with 5 sides? Even if it has one set of parallel sides, can that be a trapezoid?
No.
Take a look at the definition of a trapezoid. Look in your glossary. And let's read it out loud. Ready? 1, 2, 3. A quadrilateral with one set, exactly, of parallel sides. So by definition, does a trapezoid need to be a quadrilateral? Can you have a non-quadrilateral be a trapezoid? No. I want to see 2 distinct piles with all of the cards separated. Go. If you sorted correctly, you should find that there's only one there's only one trapezoid in this pile. Okay, let's take a look. Okay, so if we look at this pile right here, this one right here is a trapezoid, right?
Yes.
Is this one a trapezoid?
No.
Why not?
Oh.
Why not? Jack?
Because it has 2 pairs of parallel.
It has 2 pairs of parallel lines, so we would call that one a parallelogram. Okay, so are all trapezoids quadrilaterals?
Yes.
So anything that I can call a trapezoid, can I also call it a quadrilateral?
Yes.
Can a polygon be a quadrilateral but not a trapezoid?
Yes.
Okay. Can a polygon be a trapezoid but not a quadrilateral?
No.
No. Good. It's important to know this, okay? This picture right here shows that if something is a trapezoid, it must also be a quadrilateral. Do you see that? But if something is a quadrilateral, it could not be a trapezoid, right? Go ahead and draw this diagram into your notebook. It doesn't need to be this big, but you need to label it quadrilaterals on the outside and then trapezoids on the inside. So in order to draw a trapezoid, you first know that it needs to have one set of parallel lines. Now if I just draw lines like this, they look parallel, but can I be sure that they're parallel? No. So in order to make sure your lines are parallel, what you need to do is you need to use the top and the bottom of your ruler. And what I mean by that is this. Let me show you. If I have my ruler, are the top edge and bottom edge parallel? Yeah. So what I'm going to do is I'm going to trace it. It's kind of hard to do on the projector. But what I would do is I would go like this, trace the top and the bottom. And that would for sure be parallel. Does that make sense? Okay, so go ahead and do that. On my trapezoid, the angles were 90 degrees, 90 degrees, 123 degrees, and 57 degrees. If you add up all the angles inside, what's 90 plus 90? 180. What's 123 plus 57? 180. What's 180 plus 180? 360 degrees. If you measured all 4 angles of your trapezoid correctly, they always need to add up to 360 degrees. So you'll notice that all 4 angles will always add up to 360 degrees inside your trapezoid. If they don't add up to 360, you did not measure accurately. Quick interruption. Remember when I was talking to you about the trapezoids and we noticed that all 4 angles add up to 360? Yeah. Did you also notice that these two add up to 180 and these two add up to 180?
Yeah, that's right.
Okay, so it's the ones that are opposite or on top of each other add up to 180 and the other side add up to 182. Now, what do you... So again, to draw a parallelogram, you draw one set of parallel lines that have the exact same length. Does it always have to be 2 inches? No, it could be anything, but they have to have the exact same length. Now, we can show that sides are the same length by drawing this. If you draw a tick mark here and a tick mark here, that shows that those 2 lines are the same length. Another word for same length are congruent. So draw that right now on your parallelogram. Can I draw that same symbol here? No, because that would show that this one is the same as those 2, but they're not. So instead, I'm going to draw 2 lines. See how that's a different symbol? I'm going to draw 2 tick marks over here to show that these 2 lines are congruent and the same, and these 2 lines are another set that are the same. Does that make sense? Yes. So add those symbols right now to show that the opposite sides are congruent. What are you guys noticing about the parallelograms? Are you guys noticing that these 2 angles are the same and that these 2 angles are the same? Do you guys see that? Furthermore, these 2 angles add up to what number? 180. And these 2 numbers add up to? 180. So all 4 angles add up to 360. Very good. We're going to move on because we want to make sure we get enough practice. So today, just in case you didn't record, we noticed that for the trapezoids, these 2 angles add up to what? 180. And these 2 angles add up to what? 180. And then for a parallelogram, these 2 angles add up to what? 180. And these 2 angles add up to what? 180. And these 2 angles are the same. And these 2 angles are the same. Very good. Quick sum up of what we noticed about angles, right? Today for the problem set, you are going to do in lesson 5.16, careful, number 1A and 1B. Then you're going to do number 2, but it's only going to pertain to A and B. And then you're going to do number 5. For 5.17, you're going to do number 1C and number 1D. 2, which is only going to pertain to C and D. It'll make sense once you look at it. And then number 4. Then you will come get an exit ticket right here and show it to me in exchange for your homework.